Welcome to Physics 310, and in this section we will learn how to solve problems related to vectors. So this is chapter 3 and we are going to do example problems of chapter 3. This is example 3.1. It says the magnitude of vector A is 10 units and the vector makes an angle of 30 degrees with the x-axis. Find the components of vector A. So what you have a vector A that is 10 units, 10.0 units, and this is making 30 degree angle from x-axis. What is the x component of this vector is going to be? If you project it, this is going to be ax, okay, and how much ax is going to be? Vector ax is going to be A, magnitude of vector A, cosine 30 degree, where A is magnitude of vector A, and this is going to be along x-axis, so you can say it is I cap. So this vector is along x-axis, so this part is the magnitude and this part is the direction. So 10 cosine 30 degree I cap ax is equal to, so ax is, if you do 10 cosine 30 degree, cosine 30 times 10, it gives you 8.66 I cap units. Okay, because vector A is 10 units, so final answer is also units. You know, this could be anything. If it is meter, this ax would have been meter. If this is Newton, the ax would have been Newton. So whatever unit is here, the same unit will come here. Magnitude of ax is 8.66 units. The y component of vector A, so this is your x-axis, the y-axis is going to be this way, and if you project along y-axis, this vector is going to be ay. So vector ay is a sine 30 degree, and this is along y-axis, so you can write j cap. This is magnitude and this is direction, where I cap is unit vector along x-axis and j cap is the unit vector along y-axis. So this is going to be ay is going to be 10 sine 30 degree j cap. So let's see what is sine 30. Sine 30 is 0.5 times 10, this is 5. So AY is equal to 5 J cap and units. Okay, so in other words, magnitude of AY is going to be 5 units. That is, AY is magnitude of AY. Let us do example 3.2. The components of certain vectors are given as AX. So there is some vector, its X component is given. Suppose there is a vector A, its X component is given AX, this way, and AX, that is magnitude of vector AX, is given 7.55 in the question. The components of certain vectors are given as AX is equal to 7.55 and AY is equal to 3.25. Find the magnitude of the vector and the angle theta that it makes with the x-axis. So this is your x-axis, this is your y-axis. The magnitude of vector AX, that is X component of vector A, AX is given as 7.55. The magnitude of Y component of vector AY, this is AY, that's the magnitude of Y component of the vector, is given 3.25. So it is asking what is the magnitude of vector A is going to be. What is magnitude of vector A? Its magnitude, that is A, is going to be, and you can easily find, if this is AX, this is AY, if this is AY, this is also going to be AY, and so it is going to be, this is right angle triangle. If this is AX, this is AY, so this is going to be, A is going to be square root of AX square plus AY square, and that is going to be square root of 7.55 square plus 3.25 square, and that gives you, if you do the square root, it gives you 8.22. Okay, so this is the magnitude of the vector, and the angle theta that it makes with the x-axis. Suppose this angle is theta. Can we find theta? Tan theta is going to be AY over AX. So theta is going to be tan inverse AY over AX. And theta is going to be tan inverse 3.25 over 7.55. Let's find out. .25 divided by 7.55 equals, and then tan inverse shift, sine inverse, cosine inverse, tan inverse. Tan inverse, this number is 23.29. 23.29 degree. Okay. This is example 3.3. A 100 Newton block is placed on an inclined plane with an angle theta is equal to 50 degree as shown in figure. If you see your book, this is figure 3.11 of your book, Nolan book. Find the components of the weight of the block parallel and perpendicular to the inclined plane. So what you have an inclined plane, and on this inclined plane there is a block, okay, and this inclined plane makes angle theta. Theta is equal to 50.0 degrees. So theta is equal to 50.0 degree. A 100 Newton block. So what is this 100 Newton means? This is going to weight of the block. Okay, weight is a force of gravity. So that's why the unit is Newton. Newton is the unit of force and weight is the force of gravity. So 100 Newton is going to be the weight, and the gravity, the weight always, force of gravity always work downwards towards the ground. So weight is going to work this way. Okay. Now we need to find out the components of weight, this weight of the block parallel and perpendicular to the inclined plane. So what is the parallel is going to be? This is the inclined plane, and parallel to inclined plane is this. Okay, along this plane. Next. Parallels along this line, and perpendicular means 90 degree. Perpendicular means 90 degree, that the line that makes 90 degree to the surface of the incline. So what are these two components of weight is going to be? One can easily prove that if this angle is theta, this is also going to be theta. It is easy to prove that. You should always remember, if this angle is theta, this angle is also going to be theta. Okay, and it's not difficult to prove that. So we have learned previously the leg that is directly connected to theta is going to be W cosine theta, and this one is going to be W sine theta. So component of weight parallel to inclined plane W. This is the symbol for parallel. Parallel is equal to W sine theta, that is going to be 100 sine theta is 50 degrees, so 100 sine 50 degrees. Let's find out. Let's find out sine 50 times 100. This is going to be 76.60. So W parallel is going to be 76.60 Newton. Okay. Component of weight perpendicular to the inclined plane is this component W. This is the symbol for perpendicular. W perpendicular is going to be W cosine theta, that is going to be 100 cosine 50 degree. Now let's find out 100 cosine 50 is what? Cosine 50 equal to times 100 equal to 64.27. 64.27. That is going to be 64.27 Newton. So that was easy example. We need to know that if this is theta, this is also going to be theta. This is the important thing, and one can easily prove it. It's not difficult at all. Let's do another example. Given the vector A is equal to 3I plus 6J. So you can say A is written in bold letter. So when I write like A. This is a vector. This is I is written as simple bold letter. So I write I cap. J is written as simple bold letter, so I write J cap. They are same thing. This A means vector A, I means I cap, J means J cap. Find the magnitude of vector A. So what is the magnitude of vector A? A is the magnitude of vector A. That's what we are looking for. And direction it makes with the x-axis. So you have, what it means that you have some vector, that is A. Its x component is 3I cap and the y component is 6J cap. Okay, so in other words, x component of vector A is 3I, y component of vector A is 6J. So magnitude of, so AX is going to be magnitude of vector A is 3. AY is going to be magnitude of vector AY is going to be 6. Okay, remember I and J are unit vectors. Okay, when I put I with 3, it means that 3 unit along x-axis. The magnitude of I is 1, the magnitude of J is 1. So what is the magnitude of vector A? Okay, that's what we are looking for. So magnitude of vector A is going to be, okay, this is AX, this is magnitude of AX. If this is 6J, this is also going to be 6J. So this is right angle triangle. Okay, so A is going to be the square root of AX square plus AY square, that is going to be 3 square plus 6 square, and you can find A is going to be square root of 9 plus 36. If you do this, this will give you square root of 5. And the square root of 45 is 6.708. So A is equal to 6.70. Okay, that's the magnitude of vector A. And the direction it makes with the x-axis. What is the direction of A from x-axis? Suppose this is theta. Can we find theta? Theta is going to be tan inverse AY over AX. To tan inverse 6/3. Okay, you solve it. Theta is equal to tan inverse 2. Okay, can you find tan inverse 2? Shift tan inverse 2 equals 63.43 is 63.43 degree. In example 3.5, find the resultant of following four vectors. A is 100 at an angle 30 degree, theta 1 is equal to 30 degree, B is equal to 200, theta 2 is equal to 60 degree, C is equal to 75 at theta 3 is equal to 140 degree, D is equal to 150, theta 4 is equal to 250 degree. And how we are going to do this? Look at this place. This is your x-axis, this is your minus x-axis, this is your y-axis, this is your minus y-axis. You have first vector 100, this is 100 at angle 30 degree. The second vector 200 at angle from here to here is 60 degree. The third vector is 75 at angle, this angle, the whole angle from here to here is 140 degree, and the third vector is 150 at an angle 250 degree. See here, there is no units are given. You know, if there is meter, this could be a displacement. If this is Newton, these vectors could be a force. Alright. You remember how to find resultant of vectors using component method? You know, the first step is to take x component of all vectors and combine them together. So Rx is sum of x component of all vectors. So what is the first vector? 100, and its x component is going to be cosine 30 degree plus second vector is 200, its x component is going to be cosine 60 degree. The third vector is 75, its x component is going to be 75 cosine 140 degree. The third vector is 150 and its x component is going to be 150 cosine 250 degree. These all x components points along x-axis, so I can put a unit vector I cap. Okay, so I cap means this is sum of all x component of vectors, and final sum is going to be along the x-axis. That's why it is I cap here. So Rx is going to be 100 cosine 30 is going to be 86.60. 200 cosine 60 plus 100 75 cosine 140. This is going to be plus minus 57.45 plus plus 150 cosine 250 minus 51.30. 51.30. Okay. So Rx is going to be 77.85. Very similar. Sum of all y components is vector Ry is 100 sine 30 degree plus 200 sine 60 degree plus 75 sine 140 degree plus 150 sine 250 degree and this sum is going to be along y-axis, so it's j cap. J cap is unit vector along y-axis. So Ry is going to be 100 sine 30 100 sine 50 plus 200 sine 60 is 173.20 plus 75 sine 140 48.20 150 sine 250 was minus 140.95 plus minus 140.95. This is along y-axis, so j cap. So Ry is 130.45 j cap. So if your resultant of all vectors R is vector Rx plus vector Ry. And this vector R is going to be 77.85 I cap plus 130.45 j cap. Magnitude of R is going to be square root of 77.85 square plus 130.45 square. This magnitude of vector R is going to be if you do this calculation is 151.91. So you have vector Rx and vector Ry and vector R. Okay, the sum of Rx and Ry is R, and we can find this angle. Suppose this angle is phi. We can calculate this angle phi. Phi is tan inverse magnitude Ry over Rx, tan inverse 130.45 over this is going to be tan inverse 130.45 divided by 77.85. If you calculate this, so phi is equal to 59.17 degree. Let's do the another examples. Given the two vectors A and B, vector A is 3i plus 2j, vector B is 6i plus 3j. Find the following vectors, its magnitude and its direction for vector A
plus vector B.
So vector A plus vector B is going to be 3i cap plus 2j cap plus 6i cap plus 3j cap. X components will add together, so it is 9i cap plus 32 is 5j cap. So vector A plus vector B. Magnitude of vector A plus vector B, this is going to be square root of 9 square plus 5 square. You can give the name to this vector. If you want, you can write this sum as another vector, that is C, vector C. Vector C is sum of vector A plus vector. So the magnitude of vector C is going to be magnitude of vector A plus B is equal to the square root of 9 square plus 5 square. So the magnitude of vector C Magnitude of vector plus vector b is 10.29. Okay, so vector a plus b is 9i plus 5j. Okay, so you have component 9i this way and 5j this way, and this is vector c is vector a plus vector b. So can we calculate this angle, direction, magnitude and direction? So for direction we can find the angle. Suppose this is 5, so 5 will be tan inverse 5 over 9. Divided by 9 and shift tan inverse. This number is 29.05 degree. How about vector a minus vector b? Vector a minus vector b is going to be 3i plus 2j minus 6i plus 3j. I can say that this is my vector c prime. Okay, so c prime is vector a minus vector b is going to be 3i minus 6i is minus 3i. 2j minus 3j is minus 1j. Magnitude of vector c prime is magnitude of vector a minus vector b is square root of minus 3 square plus square. Okay, and this is going to be square root of 10. This is going to be 3.16. The new angle phi prime, you can calculate. Phi prime is tan inverse with the same logic minus 1 over minus 3. Minus minus will cancel out, so it gives you one over 3 shift tan inverse equal to is 18.43 degree. So how this C prime is located? C prime is minus 3i this way and minus 1j this way. This is along negative x-axis, this is along negative y-axis, and this angle is phi prime. This angle is going to be in the third quadrant. Also we need to find vector b minus vector a. So vector b minus vector a, I can say that C double prime this vector is. So this is going to be 6i plus 3j minus 3i plus 2j. So C double prime is vector b minus vector a. 6i minus 3i is 3i. 3j minus 2j is 1j. Now magnitude of vector C double prime is magnitude vector b minus vector a is going to be square root of 3 square plus 1 square. This is going to be 3.16, and this vector b minus a is 3i along plus x-axis, 1j along y-axis, and this is your C double prime is vector b minus vector a. Suppose this angle is phi double prime. So phi double prime is equal to tan inverse 1 by 3, and that gives you 18.43 degree. Phi double prime is tan inverse 1 over 3, that is 18.43 degree. The concept of 2 dimension can be extended to 3 dimension if you have vector a. So what will be the magnitude of vector a if it has a x, y, z components are given? So if you have vector a is axi plus ayj plus azk, so magnitude of vector a is going to be square root of ax square plus ay square plus az square, and so the magnitude of this vector a is going to be square root of 4 square plus 3 square plus 6 square. This is example 3.7. It is telling that given the vector a is equal to 4i plus 3j plus 6k, find the magnitude of vector a. So this is in 3 dimension, and that's the magnitude is going to be. You can find out. So this is going to be 7.8. This is example 3.8. Given the 2 vectors a and b, find the resultant vector and its magnitude. So resultant vector means I have to sum these 2 vectors. So vector a plus vector b is going to be 7i plus 2j plus 8k plus minus 4i plus 5j minus 3k this is 7i and this is minus 4i, so this is going to be 3i. This is 2j and plus 5j is going to be 7j. This is 8k and this is minus 3k, so this is going to be 5k. This is vector A plus vector B. Magnitude of vector A plus vector B, square root of 3 square plus 7 square plus 5 square, and that is going to be square root of 83, that is equal to 9.11. You can say that this sum is as another vector R. R is sum of vector A plus vector B, or you can give any other name, it doesn't matter. This is magnitude of vector R.